Hello, everyone, and welcome to week 5 of the Genomics in the Cloud Book Club. I'm your host, KT Picard. Today, we'll be covering Chapter 4, First Steps in the Cloud. We'll go through our usual talk and additional resources. A little different today is that most of the time will be spent as a working session. And that leads us to this week, which is my pleasure to introduce our guest speaker. Many of you may be wondering if we're going to get past the theoretical and gain some experience, hands-on experience with the Google Cloud Platform. And today we're honored to have someone whose background is a perfect fit as we take our first steps into the cloud. For the past 9 years, our speaker has been with the Broad Institute in Massachusetts, where she is currently the Director of Outreach and Communications. She's an educator and advocate for GATK, Cromwell, Waddle, Whittle, and Dara, all topics that we'll cover in later meetings. In addition to being co-author of our book, Genomics in the Cloud, she has a PhD in microbiology from Université Catholique de Leuven in Belgium. Our guest has been extraordinarily gracious with her time, and I've enjoyed learning more about her from her writing, as well as our late night exchanges on Twitter and Slack. I joke that we're both homozygous for the late night gene, and I look forward to her continued participation in our book club. Please welcome Dr. Geraldine van der Ore.
Geraldine. Thank you so much. Thank you so much for this lovely introduction. It's really a pleasure. I will say it's rare. I mean, this is my first book, so I can't say I'm a longtime author, but it's a rare pleasure to be able to kind of get insight into how it's working for people. That's one of the things I really look forward to, and to get, the impressions of the readers in their own words, kind of. So I lurk a lot. I hope you all don't mind. Okay, so let's get started. I'm going to pull up my presentation and share screen. All right. Okay. So hopefully you can see my PowerPoint. I'm going to put it in presentation mode. Does that still work? Everybody can see it? Yeah, okay, cool. So let's talk about this chapter, which is really, as Katie said, the first hands-on chapter in the book. I'm going to try to keep it brief, but I want to do a little recap of the main things we cover here. And then hopefully we can talk about how it's working for everyone and make sure, because we really want to make sure that it's working for everyone, because a lot of the book hands-on exercises are going to depend on everything from this chapter working smoothly. Okay, so first, just to get a few things out of the way, we did set the book in Google Cloud. From some of the discussions from previous episodes, it sounded like Google is kind of a new cloud for those of you who have already worked in the cloud, for many. And so I wanted to just address like why Google Cloud and how what you learn here would apply elsewhere, without going into the details, because the details are worth discussing over drinks. I would say that the main reason is that we decided kind of early on to use the stack, the genomic stack that's used at the Broad Institute, which is where I work, where the GATK is made. And so it made sense to us. We did consider using other software. There's a lot of other software, and there are obviously other clouds where you can do genomics. We considered originally showing different facets, different software in different clouds, but we realized as we fleshed out that outline that it ended up feeling very scattered, and that we could tell a tighter story, something, and give a kind of a more streamlined educational experience by just picking one and going through the various steps of what it would look like. And so we chose Google Cloud, but most of what we show here, aside from small, interface details and command names and things like that, all the concepts will apply generally should apply generally to working on other clouds. And we do have some plans, Brian and I have some plans to write blog posts showing how you would apply what you learned in the book to other clouds, to other pieces of software. 2020 has not been the best year for side projects, but hopefully 2021 will be more kind to us. Okay, so from the get-go, hopefully most of you have done your Google Cloud account setup by now. If anybody has had any trouble, we can go over that. Really important, if you're eligible, is to get those $300 free credits, because that's going to allow you to do all the exercises in the book without spending a cent from your own pockets, which is really nice. The services that we use in the book, the Google services, we're going to use Cloud Shell, which is a free service that offers you a basic virtual machine from which you can already interact with Google Cloud and get used to some of the basic services. We're going to show using Google Cloud Storage. So that's managing files and data in the form of files with a tool called gsutil. And we're going to use Google Cloud Engine, which is the, I want to say simplest. It's very powerful, but it's also kind of simple to use at an introductory level, which is a service that allows you to request custom virtual machines. And most of the book, I want to say at least the first half of the book, uses a virtual machine that you set up in Google Cloud Engine. So getting familiar with that is going to be really important. There's a few other things that we use in the book later in the book, but we're not going to cover in this chapter. And I do want to point out, we don't use this in the book, but for tabular data, which would include things like variants, there is a service that's called BigQuery, which is a data store that you can use as an alternative to working with things like VCF files. We didn't cover that in the book, but I think that might be one of our blog posts that we do. It's an interesting way, interesting alternative to working with files for variant level data. But let's zoom straight into what we do use in this chapter. First, we have a kind of a little tour with Cloud Shell. And Cloud Shell, like I said, is a free service. It gives you a basic virtual machine, which is pre-provisioned for you. It's not going to allow you to do any real genomics work, but it is very convenient for learning initially, and also for if you have a quick little task, you need to manage some files in your storage buckets or something like that. It's very convenient. I find myself sometimes spinning up Cloud Shell, opening up Cloud Shell just to test a GATK command, just to test syntax or something like that. And you can access it whenever you are in the Google Cloud console. You can access and start Cloud Shell. You just look for that little icon that's circled in the picture, and then you have access to your free virtual machine, which is very convenient. So in the book, we start out with that, because then you can very quickly get to working with gsutil, which is a file management utility package. And that's a nice way to kind of get to grips with how do you work with the data that's in the cloud. Something that people often tell us, it's like, if I have my data locally, it feels like it's close to me and I understand how to interact with it. But when it's in the cloud, how am I going to work with it? And the basic answer, it's not the complete answer, but the basic answer is with gsutil, you can basically interact with the files using the kind of traditional Unix commands you know and love. And you can see that the Google folks have put some care into making sure that you can interact with your file. Do things like list the contents of a bucket. So the bucket is your storage units. You can list the contents of a bucket. You can copy files around, do things like that in a way that should feel very familiar if you've used Unix commands before. creating and working with buckets as such there's a few special commands, but the only thing that's can be challenging, or if not challenging, awkward, is that your bucket name has to be unique across all of Google Cloud. This is a stumbling block for some folks. It has to be unique across all of it. So, for example, I tested these commands last night. So GS my totally unique bucket is now taken. You cannot use that. If you copy it, you will get an error because that bucket name is taken. So when you're making your bucket names, you have to be a little creative. Anyway, the other thing is permissions. Permissions kind of and access controls and stuff like that deserves to be an entire session on its own. So I'm not going to go into detail, but the Google documentation is pretty good on that. They have a lot of examples that show you different configurations. If you want to make something private, if you want to make something shared with some people, not with others, they have a lot of examples. Next, we move on to how do you actually do work, you know, with files in the cloud. And here we're entirely going to work with Docker, through Docker. And this is not required if you're working with a virtual machine. You can install things directly on your virtual machine if you want. We took the view with the book that you should be using Docker's containers in general as much as you can, because it allows you to really have this little isolated environments that you control really well, and that's completely reproducible by somebody else on a different machine. And so to remind everyone, the way it's kind of works is you'll have a registry, which is the place where container images are stored. You do a command called docker pull to pull the image, really download the image to your virtual machine. And then docker run is a command to spin up the container so that you have, I want to say, I keep thinking physically you have the container, obviously not physical, but you have the container itself, the instance will be running, and you can do work with it. So that's the stage where you can get stuff done. Okay. What the commands look like are fairly simple, and we go over that in the book. We give a few different examples, but the ones that you'll end up actually using, the Docker pull is very simple. One thing I want to highlight is, you know, if you're pulling something that's from the core library, from Docker Hub, for example, you can just say Docker pull Ubuntu, and boom, you have a Ubuntu container with the Ubuntu operating system. But all other things that are not part of the core library, you have to have a prefix that says, that's basically who is publishing this container. So that's why I put it in gray here. So you retrieve the container image with the docker pull commands, you spin it up in interactive mode, because you're going to actually log into your container to do work. So the second command there is showing the basic way to run the container interactively. And the way we're actually going to run it in the book is Docker run with a mounted volume. And the idea of the mounted volume is that you don't want to copy your data inside the container. But what you do is you have a directory, for example, on your virtual machine where your data lives. And by mounting the volume, you're basically making an alias or shortcut or tunnel or, you know, find the metaphor that works for you for conceptualizing the fact that you're going to be able to access the contents of that directory from inside of your virtual machine. And the nice thing is that you'll be able to access it from other containers as well. Okay, so Initially with Cloud Shell, we show you how to do it with a very simple container of the Ubuntu system. Later, we show you how to do it with the GATK container. And we've represented kind of what the file system looks like inside of the container. But in both cases, if you use the same setup for the mounted volume, you're going to be able to use the same original data. And you can also write back out to that directory. Okay, so that's kind of the setup we use. And we're going to be using that throughout the first half of the book up to chapter 10, really. Okay. Now, that's up to here. We do all these exercises on Cloud Shell, where we're really just practicing these basic commands and interacting with the pieces. In the second big section of this chapter, we actually leave behind Cloud Shell because, as I mentioned, Cloud Shell is pretty limited. It's a puny little virtual machine, and you're not going to be able to do real genomics work on it. And so we take you to the Google Cloud Engine in the Google console, and there we walk you through creating a custom virtual machine on GCE. And for that, I will say it's a series of forms. We walk you through it in the book. I found that the first time I used this, there were a few things that I had to kind of research what makes a difference and so on. And I will say that the main things at a basic level that you want to care about are the region and zone that you choose for your virtual machine. And that will actually apply to buckets too. And that really refers to the physical location of your data centers, the data centers where the machines that you're going to be using actually live. And the region and zone thing is worth looking into a little bit. There was a really helpful and amusing blog post that we found while writing the book that explains it, kind of how it's set up in a way that compartmentalizes so that the cloud provider can swap resources in and out depending on how much utilization there is, like how much people are using machines at any given time, but also set up things like backups and fail-safes so that as a user, we don't really perceive all the complexity that's happening, but there's actually a lot that's happening on the provider side to make sure that what you're working with, where your data lives, and so on, just continues to work as far as you're concerned. But if there's a power cut, or as they say in the blog post, a zombie apocalypse, things will continue to work for actually quite a long time because of how that's set up behind the scenes. Anyway, it's interesting to look into, but if you want to stay at the basic level, just pick a region that's close to where you are geographically and or close to where your data lives, because even though data transfer in the cloud is really fast, there's still, like, if you're transferring it across the world, it still takes some time, and you can get into tricky places where in some cases you might have to pay a fee to transfer data across regions and stuff like that. So to keep it simple, try to keep things geographically together. Okay, machine type, what kind of processor you want, how much memory do you want to give it. That's fairly straightforward. What's not so straightforward is that you can either give kind of custom specs, or you can choose from a list. And there's like a whole menu of N1, N2 standard. There's kind of pre-made bundles that you can select from. And in the book, we choose some basic ones, but you can kind of experiment and see what you need. You have the possibility of installing a container on the VM up front. We didn't use it because we intentionally want you to have to go through the steps of getting a container and setting things up, because it's a good skill to have. but there are some shortcuts that you can take in the future. And of course, you choose a boot disk, which is going to determine the system, the OS that you want to use and stuff like that. And again, there's a predefined list that you can pick from, and we selected something that we knew should work for everyone. Okay, once you've spun up your virtual machine, you're going to log in over SSH, which is just a communication protocol that allows you to connect to your VM securely. And then once you're in, it feels pretty much like any other machine that you would use from the terminal. There's some authentication to ensure that your credentials are set up so you're not going to run into permissions errors. And one thing that is important to say, what we show in the book is a basic setup where you're using your personal credentials because it's easier. When you're doing real work with a team and stuff like that, you will have to look into using service accounts and setting things up securely for sharing resources. The clouds can be very secure. Some people have some misconceptions about how secure the cloud is. It's as secure as you set it up to be, and it's what we show here has some vulnerabilities. So it's fine for practice with public data, but if you're setting up to use the cloud directly, not through a managed service yourself, you want somebody who's an expert to help you make sure that everything is set up securely if you're using human data and stuff like that, okay? All right, so once you're in your virtual machine, we're going to have you copy the example data that we provide with the book, which is in a public bucket. So we have you copy it over so that you can work with it. We also have you install Docker, the Docker software itself on the virtual machine because it's not pre-installed on the boot disk that we selected. You're going to pull the GATK container. Here we're pulling it from the Google Cloud Registry. It's also available in Docker Hub, but Docker Hub recently imposed some limitations on how much you can pull and stuff like that. We had already set this up to use Google Cloud Registry anyway, because it's slightly faster if you're using the Google registry. But know that if you're working on AWS or whatever, you can also pull from the Docker Hub. I think you can also pull from GCR from other clouds. I assume so. I have not tried it myself. And finally, we use the interactive Docker commands with mounted volume that we showed you earlier, but this time, this is the real version with the GATK container that you're going to be using in multiple subsequent chapters. And once you're in it, you can test that GATK runs, and with GATK 4, I'm happy to say that it's stunningly easy. You just type GATK return, and it should work. So within the GATK container, everything is set up, including with a little shell wrapper that allows you to invoke the GATK, which is still, a Java application. So the shell wrapper is going to translate what you provide as GATK, rest of your commands, it's going to translate that into a proper Java command with Java jar or whatever. But the team has wrapped it to just make it easier to type your commands. So to test it, just GATK, and you should get the help message show up in your terminal. And that's really it for the basic setup of what you need. If that works, and if you can access the data through the mounted volume, you should be good. We do give you a little bonus setup tips. We use the IGV genome browser to actually visualize data throughout the book. And you can actually set up IGV to connect to Google Buckets. So there's a little bit, you have to go in the preferences and, log in with your Google credentials. And once that's done, you can give IGV file URLs pointing to bucket locations and view that in the IGV genome browser, which is very helpful. So you don't have to start downloading things just to see what the results were of commands. And remember, when you're done working, stop your VM. Don't delete it because you're going to need it. Need the same VM for a lot of exercises, but stop your VM because as long as it's running, it's costing you money. So, you get into the holidays or something like that, go on vacation, stop your VM. The VM we work with in the book is pretty small, so it's not huge in terms of expense. But we have horror stories from the development team from when we started working with the cloud, people who forgot to stop like large Spark clusters and cost embarrassing amounts of money from oversights like that. You don't want that to be you. Stop your VM if you're working with it directly. We'll see later in a managed service like Terra, there's actually, the system will manage that for you, stop VMs and stuff like that. If you're working directly, remember to stop your VM. And that's all I'm going to say. And we can move on to the working session, but that's a really important point. There are a few additional resources. I think it would be great to crowdsource some additional pointers to resources for getting started with the cloud. I added, Terra has a brand new outreach website that includes a new to cloud orientation page that hopefully is a little bit helpful. It's pointers to specific parts of documentation, including Google Cloud documentation. Google Cloud Docs are really of good quality overall, but there's just so much, it can be hard to navigate. So we try to identify a few pointers that are the most useful for most people starting out. But I'd love to hear what other people suggest to get started and to have equivalent resources for the other clouds. And that is it. Well, don't go yet, right? I'm gonna hand the mic back to KT, and then we'll figure out what's helpful to everyone. If there's questions, I'd love to answer, but I'd love to make sure that everybody has the opportunity to work through everything and that everything is working, and that we address any technical issues.
Geraldine, thank you so much for that introduction. And I must say, it was a bit of magic for me last night. It was kind of last night or yesterday, but when I went through the book and spun things up, I've been using Unix for over 30, it's hard even to say, 30 years. But I've never used a Docker image before. And it was honestly kind of magical to bring in something that actually worked out of the box. The mount points are brilliant, that you can share back and forth between your VM and the cloud instance. I don't know what others experience. Other members may have had experience with Docker before, but anyway, well written, easy to follow for me in terms of the steps to walk through it. So thank you for a really well written chapter that was a nice introduction to cloud, not only from a VM perspective, but also from a Docker and GATK perspective. Like I said, straight up, just worked 100%. Had no trouble with it.
I'm delighted to hear that. I will say I first heard about containers years ago. I want to say like 2014. One of the engineers, Khalid, kept talking about how we should really be using containers for GATK and would save us a lot of trouble. And I was resistant because it seemed so complicated. I didn't understand how it worked. I was really worried it would be super hard to use. And I think this is terrible, but it probably took 2 years plus before I actually tried it. And this is one of my lessons learned is just trust Khalid. Trust him. This is not the first time. Anyway, he just he walked me through it, and I finally realized that it can be stunningly simple. I think what's can be hard and maybe a little paralyzing is that so much of the documentation or the resources that you can find online about Docker and various flavors of containers are written for people who want to run applications in the cloud, like running a web service or stuff like that. And that is complicated, but if you're just doing it yourself, like on a VM, it is, I don't like to say that something is super easy, because if somebody runs into trouble, then they feel bad, and I don't want them to feel bad because it's not their fault. But it is surprisingly less complicated than you might think. And once you try it, it's like, oh my goodness, now I don't have to figure out all the dependencies for this weird package. If the author did their due diligence, provides a Docker container, I can just use it out of the box. And everybody who's making software should provide containers, especially academic software with weird dependencies. No judgment, but please. Anyway, that's my soapbox.
No, I couldn't agree more. My previous experience was using VM images, and those VM images were, I don't know, between 60 and 80 gigabytes each, right? And so every time that we had to push out, do software, we got better at it. But anyway, there's great advantages to removing a lot of the, well, I guess putting a lot of the infrastructure, relying on the infrastructure that's in place in cloud, right? And building your application on top of that. So anyway, a lot of fun. There was a question on the chat from Adelaide. I did want to start with that. You mentioned the public genomic data sets like GeneNomad that are available through Google Cloud. And her question was about the region. We were talking about, you know, are those in, do you know, because you were talking about movement of data and trying to minimize that. Is there a specific place where you know those data sets are stored?
Oh, so actually the data sets of wide interest, I forget how they're called, but certainly Nomad is one of them, and there are 1,000 genomes data, stuff like that. They're in, I should have mentioned, there's a special bucket setting that's basically international. And so they're not subject to the rules about if you move things between regions. And so anything, and pretty much all the public data that the Broad makes available is also in these basically region-free buckets that are accessible from anywhere. I assume that on, you know, behind the curtain, Google has copies in multiple places that are regionalized, but yeah, so it's more expensive for storage. So the ones, Nomads is part of program that's funded by Google, and so they make things available for free, and they just eat the storage cost. But for things that the Broad makes available, well, we try to put as much of that as possible in the Google program, and for what we can't, we still put them in the region-free buckets, because it makes it more accessible to everyone, and that's our goal, to just make sure everybody has access without having to pay any kind of penalty. It costs a little more, but it's worth it.
And just a shout out to the Broad, and with our thanks, I noticed in the book there was mention that they were picking up the egress or, you know, data transfer fees. So much appreciated from our members, certainly.
It's part of the Institute's mission. So, but I'm glad it's appreciated.
Very good. Well, let's open it up to the members. We have about I think almost a dozen now of people online now. General questions that folks that have given this a try or are getting ready to. Curious for your questions and comments for Geraldine.
I have a quick question. Can you hear me?
Yes.
Hello.
Yeah.
Oh, no, thank you. That's a great introduction. You mentioned about the cost of the VM. And I'm wondering if you can give us maybe little anecdotal ideas of what does it really cost to do a serious analysis? Are we talking about pennies or dollars or tens of thousands of dollars? Or is this the kind of thing that to do what you do, we're spending millions of dollars a year on Google Cloud? Or can you just give us maybe some anecdotal ideas of roughly what the costs are like? I'm a little bit afraid of doing too much because, I know we've got that $300 credit, but how fast will I burn through that if I start going after my own BAM files or something?
Well, I think Mathieu actually has some interesting perspective from the trenches of having done real analysis as part of his work with the cloud credits. I will preface that by saying it depends. Well, for one, it depends what you consider a real serious genomic analysis. Are you working with just on the variant side, but I would say if we mean serious as in serious processing things from FASTQ or BAM, all through doing things like alignment and variant calling and so on. It's not trivial, but it depends a lot how you set it up. And we spent a lot of effort optimizing for cost. There's a lot of talk about optimizing genomics for speed. And I think that's a lot based on when you have on-prem systems, you have to optimize for speed because you need to evacuate data, get it through and get it out of your way so you can analyze whatever's coming next. With the cloud, it's a little less, you have less of that pressure because within reason, you can always just request more VMs, right? So we optimize a lot more for cost than for speed. And as anecdotal data points, when we originally started moving the Broad's production pipeline to the cloud some years ago, 4 or 5 years ago, it cost, I think it originally cost in the $80-ish per sample. We pretty rapidly took that down to $45 per whole genome sample for going from like FASTQ to called variants. Then we sat down with Google Cloud engineers who walked us through a number of tricks and functionality. Some stuff was developed for the occasion. And we got it down to $5 per sample. So from an initial $80, and it's something that some commercial services will bill you $100 per sample, right? Took it down to 45 fairly easily, down to 5 with, that was 2 years of concentrated work. But now we have optimizations and kind of ways of doing things that just are very cheap, taking advantage of things like preemptables, which are analogous, not exactly, but like spot instances on AWS. It works a little bit differently, but the same idea of you start working on a VM, but it can be taken away from you at any point if there's high utilization and somebody else needs a VM and didn't check the preemptible option, then they get preferential treatment and the VM will be yanked away from you. You lose what you've done so far, but the VM costs like 20% of the normal cost. And so with that, it means that most of the time, especially for short running jobs, most of the time your jobs will run to completion for 20% of the cost, which is a huge savings in itself. And we use that throughout all our pipelines now. And there's other ways to kind of take advantage of how things are set up to make things really cheap. Auto sizing instances. So in the pipelines, we have some logic to make sure that we're only requesting as much disk or as much memory as a particular job needs automatically, so that we don't pay for super beefy instance just because, some samples are unusually larger than others. Normally you would kind of set the parameter to accommodate the largest size, maybe. That means spending a lot of money on space that you don't need most of the time, but we can, the WDL pipelines have some logic to be able to say, based on the size of the input files and the ratio that we know, like for this particular process or transformation, the output is going to be a tenth of the size or twice the size or whatever. You based on experience, you figure out a simple arithmetic rule, and you auto size how much space you want in total, and that ends up actually saving us a ton of money, just by making sure that we're only requesting specs that make sense for that particular job. Other stuff like that ends up streaming also. Streaming is a really important one. You might have seen on one of my slides when I was talking about retrieving the data to the VM. Technically, GATK can read and write directly from buckets. So in production, we don't copy the entire whole genome to a VM. We'll actually just stream, because we're parallelizing over genomic regions. And so for any given instance, any given job, we'll just stream that little piece of data. And that means that we can use much smaller instances in terms of disk size. So there's a number of things that you can do like that ends up saving you a lot of money. So like I said, we got it down to $5. That was before the whole Spectre exploits. Spectre and Meltdown, I think, were two exploits that came out a few years ago. And unfortunately, on all the quote unquote older hardware, they had to put in some security patches that slow down processing. I'm not sure why. I don't really know enough about how that works, but that ends up costing us a couple of dollars more per sample. So that's not great. So those are now at like $7 or $8. But the newer hardware, as they roll out new hardware that doesn't have those vulnerabilities, we get back down to the lower cost. Anyway, that's might be more than you were expecting or hoping to hear about that. But it should give you a sense. But again, that's if you're running pipelines that are optimized, it can be quite cheap. Oh, Mathieu, maybe you can share your experience.
Thanks, that's very helpful.
So yeah, I should preface by again repeating what Geraldine said, which is that I ran my analysis on Terra, so it's obviously very optimized in a way that perhaps like running it directly on a virtual machine from a container wouldn't be. So what I managed to do was with the 300 dollar credits that I had, I managed to run, I would say probably 95% of a project that I had, which involved recalibrating 828 exome BAM files and running them through germline CNV caller, which is a tool in beta. I think it's still in beta now, which calls copy number variants. So I don't know how it compares in terms of computational complexity with haplotype caller, but I imagine it would be quite a computationally intensive tool. So the fact that I managed to run most of the project on those 300 credits it was pretty good. I think in the end, the whole project cost me maybe $12, $13. The rest being covered by the 300 free credits. So there's all you can do. Obviously, one thing that's changed is that I think, and someone was mentioning in the chat, I think now you only get 3 months of free credits. When I did it, it was an entire year. So I was able to spread the project through a year, which you need when you're working with 800 samples. But yeah, no, you can do. I think especially with Terra, there's a lot you can do in genomics with those credits.
Yeah, I will say that the pipelines, if you run the same pipeline that you would run in Terra, but run it using the stuff we show in chapter 10, which is the same underlying infrastructure of Cromwell and the Life Sciences API, Pipelines API, that should be the same. Like the cost should be the same, because Terra doesn't add any optimizations. It's more the convenience of managing the executions. But in terms of pipeline optimization, it's the same if you run it straight through Cromwell, like if you manage your own certain Cromwell server. But I appreciate the the advertisement.
Great, Matthew and Geraldine, thank you for that. And Richard, I'll just add, I did a side-by-side of AWS with GCP, and I found kind of at the 10,000 meter, 30,000 foot level, they're equivalent in terms of cost. The storage costs across the board were down to the hundredth of a cent even. There are some differences in the way you can prepay for computational resources, but they both have kind of preemptive options and ways to reduce cost in terms of compute. I think maybe GCP has a little bit more in terms of the way that they've done. I don't know. Some of the cloud and container stuff is pretty cool. They've recently made that easy for other people to build things as well. But in any event, just wanted to add that, so that if you have experience with AWS, I think you'll find the experience is a little different, but cost-wise, it's really amazingly similar. Yeah. Geraldine, there's another question on the chat. Actually, let me just preface this. We have members who have mentioned before that part of the reason that they're here is kind of to bring cloud DNA into their research centers. And what I mean by that is they've been working on clusters, and moving to cloud is something that either may be challenging for their research institute, or even where they live, it's just something that's just kind of becoming more accessible, in kind of depending on where you are. I'll let Amit kind of talk to this a little bit more, but that's kind of it's kind of a question that's come up from a lot of our members. But Amit, would you like to add to that?
Sure. Can you hear me fine?
Yes.
Yes. And sorry, is it Amit or Amit? I'm sorry.
Yes, it's Amit.
Great. Welcome.
That's fine. Yeah. So hey everybody. I didn't get a chance to introduce myself. So for those who haven't seen the text, or I'm just blabbering here, but yes, I work in a clinical lab, and we are always looking for ways to integrate technologies into our workflows. And it is often difficult because there is a element of HIPAA compliance where the patient data and the security aspect comes in, and we are always curious how we can integrate these technologies in the clinic, because clinical labs are a little slow when it comes to adapting these technologies, and I would say a little reluctant as well because of the HIPAA and security issues. So I would like to kind of know, like, what would be your advice to someone working in a clinical lab on how to get started in cloud? That would be a good starting point.
That's a big question. I would say, I mean, so it depends. It depends a lot on the resources you have available. It's kind of ties back to what I was saying about how the cloud is as secure as you make it. There's a lot of, all the infrastructure is there for making things secure enough to work with patient data, clinical data. But it's a complex environment for regulatory reasons and technological reasons. And so we found that we have a full DevOps team that is very focused on security. If you have the ability to, if you want to work with a cloud directly and set things up on that. You need like a specialist team who is going to be doing that professionally full time. Would be my impression. Again, I'm not a security specialist, but that's the impression I've had working with people who are. The alternative is to use a managed service. Terra is one of them, but there are other people who offer services to help maintain your data in a secure way. I'll speak briefly about Terra. The goal of Terra initially for the Broad was to make it easier for Broad scientists to work with the cloud, because we found very rapidly that moving our production pipeline was one thing, but then getting all the scientists in just various research units to actually work with data that was on the cloud was not trivial. Because the interfaces that are provided and so on are very powerful, but there's a lot of complexity, and I don't think it's reasonable to expect research scientists and clinicians and people like that to all become fluent in the intricacies of cloud. And so the goal was to build an interface that would help with that, to make it easier to have data that needs to be secured in the cloud, work with it, collaborate with others, especially collaborate with other research teams around the world, and do that all in a way that is safe, that respects local and global regulations. There's a lot of layers. And so there's a kind of a cloud ecosystem that has been forming, and it's not just us either. There's a number of other institutions who are working on this with backing, with support from various NIH agencies in the US, and there's other initiatives in other countries to make, build biobanks and stuff like that, to help build structures that are specific for the specific challenges of biomedical and clinical practice, clinical data, because there's a lot. So I would say for I would generally think that a team in a particular clinic on their own is going to struggle a lot to do it all by themselves, because there's so much going on. At the same time, if you have the ability to have a dedicated team, it can be done. It's just complex. And there are collaborative efforts through, one shout out I'll make is GA4GH, the Global Alliance for Genomics and Health, which is a volunteer-based organization that kind of spans the globe and attempts to build standards and define ways to do things that will allow us to work collaboratively with genomic data in a way that's safe, but also ethical. Because that's also a big dimension of the problem, is it's not just keeping the data safe, but also having the ability to enforce ethical requirements, like being able to withdraw data when a patient decides to withdraw from a study and stuff like that, being able to share data with researchers in a way that respects consents, in a way that's scalable and efficient, all of that. I don't know if that answers the question. That might have just added more fuel to the fire. But that's the landscape out there, and that's honestly worth a whole hour discussion.
Yeah, we are a small clinical lab, and I feel to a lot of extent we do find ourselves in that tricky area that you're talking about. It is always the patient data security and privacy is always major concern to even move data on HIPAA clusters because I wanted to test some pipelines out and I wanted to try the university HPC infrastructure and it was a very rigorous process just for me to try out the pipelines, and they wanted to make sure that I'm using the public data as opposed to patient data, and so I just ended up using the GIAB data to try the pipelines out, and then we integrate these pipelines locally, not even on the clusters yet. So we are in the process of kind of moving to clusters right now and considering the options of moving to cloud as well. And I think I agree with a lot of what you have to say. It's tricky, and it's a tricky area to be in for clinical lab.
Yeah.
And I think we're all kind of pioneers here, and I think that's one of the exciting parts about being part of this is that it gives us, because this infrastructure allows us to work even on public data sets. It does allow us to dip our toes in the water, so to speak, and try all of this, even if it may be difficult where we work or where we live. So we have time for one more question before we wrap up. One other question from the team before we'll call it a year.
Yeah, did anybody already work through this chapter and struggle with any particular points? Because I do feel like we promised a working session, then I talked a little longer than I expected, which is always the case. And we've had these very interesting side conversations about the topics, but were there any very concrete questions about stuff that didn't work? I really want to make sure that everybody can get working hands-on with the exercises moving forward.
I can jump in here. So I have worked on these exercises and I have followed the instructions step by step. I would say that if you follow the instructions step by step, it will work. And it has worked for me. I have successfully run, I believe, haplotype caller, like installing GATK using Docker and running haplotype caller. It all works very smoothly if you follow the step-by-step instructions in the chapter.
Cool. I like to hear that.
Okay then. So Geraldine, thank you again so much for spending this time with us to walk us through chapter 4. Next week we'll be covering chapter 5, which is the introduction to GATK itself. We have another guest speaker that will be picking up that chapter. So looking forward to that. I wanted to let everyone know I'll post the links. Adelaide, thank you for posting things as we walked along today. So I'll put those links on Slack. Any other final thoughts before we finish up our last meeting of 2020? I think all of us are looking forward to getting this year behind us, right?
Oh yeah.
I had a final question. I didn't say it earlier because I didn't think it's that important, but I was kind of curious to know the IGV option to pull files from the Google Cloud storage. How long has that been part of IGV?
I think it's been at least 2 years, because that's when we started using it in workshops. I think it might have existed before, but I've been aware of it for about 2 years.
Yeah, I discovered it yesterday, and I was kind of blown away by that. It's a small thing, but I was like, oh, okay, that's an IGV. Oh, that's great.
Very convenient.
Yeah. Also supporting CRAM files now, IGV. That's been for the last, year or two. So yeah, a really nice resource. I'll just let everyone know on the Slack site, we have a specific area for the cloud. And so if you have other questions there, that's what we'll be looking at over the next week to share information about questions as we get started. And as we've been going through, again, thank you for your posts over the last week. I've really enjoyed the discussions. I'll be sure that we have one more discussion. You mentioned the ethical issues earlier. we'll pick up a thread on ELSI, the ethical, legal, and social implications of genomics. We'll weave that in as we go along in the next 14, through the chapters. So I think we'll put a pin in it. Again, thank you so much. I want to wish everyone all the best and much happiness in 2021. And we'll pick up again in the new year. So thanks again to Geraldine for your time today. And right, thanks everybody. We'll see you next year.
Bye everyone.
Okay.
Thank you.
Bye-bye.
Thank you.
Happy New Year, everybody.